Imagine a room, not unlike a cathedral of science, deep inside a University of Michigan lab, a space dedicated to pushing the boundaries of human knowledge. It's silent except for the low, constant hum of computers, the quiet breathing of sophisticated machinery, each piece of equipment meticulously calibrated, waiting for its moment. Scientists, the architects of this experiment, gather around a glowing control panel, their faces illuminated by the soft light of the monitors. Years of meticulous planning, countless calculations, and tireless work are all culminating in this single pivotal moment. The air is thick with anticipation. A finger, steady and deliberate, presses a button. The culmination of preparation meets the spark of action. Instantly, ZEUS, the zettawatt equivalent ultra-short pulse laser system, and the world's most powerful laser, roars to life, a controlled explosion of energy waiting to be unleashed. For a fleeting instant, a mere fraction of a second, it unleashes a pulse of energy so intensely concentrated, so unbelievably powerful, it outshines, for that briefest of moments, the combined electrical output of the entire planet. Every power plant, every generator, all focused into a single point. This isn't some far-fetched science fiction scenario pulled from a movie. It's happening right now, in a real laboratory, with real scientists pushing the very limits of what's possible. All the power plants on Earth, working in unison, are crammed into a beam of light smaller than a needle's tip, a testament to human ingenuity and the power of focused energy. That incredible feat of engineering, that concentration of power, that is ZEUS. The very air around the device crackles with raw energy. For a fleeting moment, this unassuming lab in Michigan is, quite literally, the most powerful place on Earth. The scientists aren't just running a routine experiment, they are voyagers on an expedition to the edge of known science. They're holding the power of civilization, the potential for groundbreaking discovery, in their hands. All this to probe the universe's deepest mysteries, to unravel the secrets of space and time. The laser pulse vanishes almost instantly, a fleeting burst of light and energy, but the wealth of data it creates, the insights it provides, will be meticulously studied and analyzed for years to come. ZEUS allows us to explore the very fabric of reality, to peer into the quantum realm. It recreates conditions found only in the hearts of stars, or in the extreme gravitational fields near black holes. This incredible machine is the culmination of a global scientific dream, a testament to what humanity can achieve when we work together. We build machines like ZEUS not just because we can harness such power, but because we must, because the insatiable human desire to understand the universe is what drives us forward. ZEUS is our window into the unknown, a portal to new discoveries. It's a tool to witness and validate physics we've only theorized about, to turn abstract equations into tangible reality. With every pulse, with every experiment, we get closer to understanding where we came from, the origins of the cosmos. And perhaps more importantly, where we're going, what the future holds for humanity and our understanding of the universe. The adventure, the quest for knowledge, begins with the simple flip of a switch. In the realm of scientific innovation, where human ingenuity meets the fundamental forces of nature, lies ZEUS. ZEUS, the zettawatt equivalent ultra-short pulse laser system, isn't your average laser pointer. It's not the kind of laser you'd use to entertain your cat or point at a presentation screen. It's a building-sized instrument, a colossal assembly of mirrors, lenses, and high-powered amplifiers. It's designed to deliver some of the most powerful bursts of light on Earth, concentrated beams of energy that push the boundaries of what's possible. Think of it as the universe's most powerful camera flash, a fleeting burst of intense illumination, capturing physics in action under extreme conditions, freezing moments in time that would otherwise be too fast to observe. ZEUS's power is measured in petawatts, a quadrillion watts, a unit so large it's hard to fathom. For perspective, a city uses billions. ZEUS peaks at 3 petawatts, briefly drawing more power than some entire metropolitan areas. But the secret is in the timing. All that energy is packed into a pulse lasting just a few femtoseconds, an incredibly short duration. A femtosecond is to a second what a second is to 32 million years. Unimaginably brief. A sliver of time that defies human intuition. ZEUS isn't just powerful. It's a unique scientific tool, a precision instrument capable of creating extreme conditions, pushing the frontiers of high-intensity physics, exploring phenomena that were once only theoretical possibilities. By focusing its beam on a tiny target, a space smaller than the width of a human hair, ZEUS recreates conditions found near neutron stars, some of the densest objects in the universe. or black holes, regions of space-time where gravity is so strong that nothing, not even light, can escape. It's like having a piece of a supernova in the lab, a controlled explosion that allows scientists to study the processes that shape the cosmos. This lets scientists test theories that were once only on chalkboards, transforming abstract equations into tangible experimental results. ZEUS is a hub of discovery, a place where researchers from around the world come together to push the boundaries of knowledge, training the next generation and unlocking the universe's secrets with light, inspiring young scientists to pursue careers in STEM fields. It's not just a machine, it's a leap forward for science, a testament to human curiosity and the power of innovation. Creating a ZEUS laser pulse is no simple feat. It requires a delicate and intricate process, a symphony of physics and engineering working in perfect harmony. It's like building a tidal wave from a ripple, starting with something small and amplifying it to an immense scale. It starts with a tiny, weak pulse, a mere whisper of light. This is a seed pulse, a carefully crafted burst of light with perfect properties, but possessing very little power. It's the foundation upon which the entire ZEUS laser pulse is built. First, the pulse is stretched in time, a crucial step in the process. This involves spreading its colors apart, like a prism dispersing sunlight, to make it longer and therefore safer to handle during the amplification stages. If you tried to amplify the short pulse directly, without stretching it first, it would instantly destroy the delicate optics within the system, like channeling a raging flood through a drinking straw. The energy would be too concentrated. Once stretched, the pulse is ready for amplification. It's passed through special crystals, carefully chosen for their ability to boost the light's intensity. The pulse picks up energy at each stage of amplification, growing stronger and stronger as it travels through the system. After amplification, it's incredibly powerful, but still relatively long in duration, thanks to the initial stretching. The final step is compression, the key to unleashing the full potential of the ZEUS laser. Diffraction gratings, acting like precisely engineered prisms, bring the colors of the stretched pulse back together, realigning them perfectly. This process squeezes all the amplified energy into an incredibly short burst, a femtosecond pulse, 1/4,000th of a second. This entire process, stretching, amplifying, and then compressing the pulse, is known as chirped pulse amplification, or CPA. It's a revolutionary technique that won the Nobel Prize in Physics, recognizing its profound impact on the field of laser science. And it's this very technique that made the creation of ZEUS, with its unprecedented power, possible. The journey from a faint seed pulse to a petawatt monster of light happens in a mere fraction of a second, a testament to the incredible speed of light and the precision of the laser system. The pulse travels across a carefully designed path, lined with vacuum chambers to prevent any interference from air molecules. Every mirror and lens along this path must be perfectly aligned, down to the micrometer, to ensure the pulse stays on course. It's a high-tech ballet of photons, a carefully choreographed dance of light and optics. This culminates in the creation of one of humanity's most powerful bursts of energy, concentrated into an incredibly small space and time. All of this effort, all of this precision, all of this technology is focused on creating a single perfect pulse of light. That's the incredible science behind the light of ZEUS, a testament to human ingenuity and our relentless pursuit of knowledge. ZEUS's power isn't about total energy, it's about how fast it's delivered. Imagine a pressure washer for light. A small amount of energy, released in a split second, becomes astronomical power. All the world's power plants generate a few terawatts. ZEUS hits thousands of terawatts, petawatts, for a fraction of a second. For that instant, it outpowers the entire planet. The sun bathes Earth in 174 petawatts, but ZEUS focuses 3 petawatts onto a spot smaller than a human hair. The intensity at that point is billions of times greater than sunlight. This lets ZEUS create extreme states of matter and energy that don't exist naturally on Earth. Its electric and magnetic fields can rip electrons from atoms and accelerate them to near light speed. ZEUS's true value isn't just its power. It's what that power lets us see and do. It's a gateway to the most intense environments in the universe. Why build a machine like ZEUS? To explore the universe's most extreme mysteries. We can't fly into the sun, but ZEUS lets us create a tiny piece of a star in the lab. By firing its pulse at a target, we make matter hotter and denser than the sun's core. ZEUS lets us test quantum electrodynamics, QED, under conditions never seen before. It could even turn light into matter, creating particles from pure energy. Scientists can simulate supernova shockwaves and study cosmic rays, solving century-old mysteries. Every time we build a more powerful tool, we discover the unexpected. ZEUS is designed to push physics to its limits and show us where our theories break down. ZEUS's breakthroughs could transform our world. In medicine, laser-driven accelerators could make advanced cancer treatments more accessible and affordable. ZEUS's research into plasmas is vital for fusion energy, the dream of limitless clean power. Understanding cosmic rays helps us protect astronauts and design better spacecraft. Laser-driven acceleration could even lead to new propulsion systems for interplanetary travel. ZEUS also helps us develop stronger materials and new ways to inspect cargo for security. The ripple effects of ZEUS's research drive innovation across medicine, energy, space, and security. It's fundamental science with real-world impact. ZEUS is the result of hundreds of passionate scientists, engineers, and students. Led by Professor Karl Kruszelnick, the team's motivation is pure curiosity about the universe. Optical engineers align mirrors with microscopic precision. Vacuum technicians keep the chambers pristine. Theoretical physicists design experiments to probe the unknown. Graduate students and postdocs run late-night experiments, making discoveries that push science forward. ZEUS is a training ground for the next generation of innovators. The work is challenging, but the thrill of discovery keeps them going. The story of ZEUS is about collaboration, perseverance, and the human drive to understand. The real power of ZEUS comes from the people behind it. Their curiosity fuels the quest for knowledge. ZEUS tackles the universe's biggest mysteries. What is the vacuum? Quantum theory says it's a sea of virtual particles. ZEUS can pull them into reality. How did cosmic magnetic fields begin? ZEUS creates turbulent plasmas to mimic the early universe. It can even simulate black hole physics, creating analogs of event horizons to test Hawking radiation. These aren't just academic questions. Solving them changes our understanding of existence. Discovering matter from light, or the origins of magnetic fields, reshapes our cosmic story. ZEUS is a time machine and a cosmic simulator. It lets us ask, and maybe answer, the biggest questions imaginable. With ZEUS, the impossible becomes possible. And as ZEUS begins its mission, we stand at a new scientific frontier. The most exciting discoveries are often the ones we never expect. Like Galileo's telescope, ZEUS could revolutionize our understanding in ways we can't yet imagine. The data from a single pulse can take months to analyze, leading to new questions and experiments. ZEUS is the starting line for a new era of exploration into the quantum realm and the cosmos. It will inspire future scientists and engineers, fueling curiosity for generations. As the team fires another pulse, they hold a key to the universe's secrets. The adventure is just beginning. What will ZEUS reveal next?